So resolving this into its vertical and horizontal components, this force here of 6 newtons, which is acting from this point down here. What is the vertical and the horizontal effect of that force? What's the vertical and horizontal components of that force? So by sketching it, you can see roughly which direction those vertical and horizontal components are going to be acting in. There's a couple of conventions we need to know when it comes to this. First of all, to do with angle, they're always measured from this positive x-axis. So I've given you a bit of help in this question because really the angle should have been measured from here round to here. So technically the angle of that force is 180 plus 40 degrees, which is 220, as you know. Or I could come round this way and it would be minus 180 minus 40, which is 140 degrees. So the angle really should have been measured from there. The other thing to point out is that if I'm going to resolve this force, I also need to have a sign associated with it. And you set your own convention here. If the problems you're associated with in engineering tend to have a load of forces acting upwards, well then I might set the up direction as positive. If I'm considering weight, I might all the time be considering down forces due to the weights of objects. So I might consider down to be positive. Up to you which way you do it. And because it's arbitrary, you need to state your convention. So if you're ever going to draw out force diagrams like this, as I'm sure you know, you must put your convention on. So if you're going to get this right, that convention must appear. Otherwise, I've no idea whether it should be positive or negative. Once we've decided our convention, then we work out the values. So this vertical component here, well, we've talked about this before. We imagine this vertical component shifted from here across to here so that we can form a right-angled triangle, and then we can find the values of these forces. So the vertical component will be this side of the triangle, and the horizontal component will be this side of the triangle. So it's just straight trigonometry now using sine and cosine ratios. So let's complete our triangle, and then we say, in this case, we've got, if we're after the vertical component, that's going to be the hypotenuse times the sine of the angle, because it's the side opposite the angle. And almost all the time that's the case, but not always, so be careful. And for this particular problem, the horizontal component of the force is going to be the hypotenuse times the cosine of the angle. So those are the two formulae we're going to use to find the size of the force. Once we've found the size of the force, we then put on the sign. So we can now calculate FV equals H times sine theta, which is 6 times the sine of 40 degrees. Which is, so answer 3.856. What accuracy do you go with? That's important to consider. Look at the force that we've got. That's to one significant figure, 6 newtons. So one or two significant figures, 3.9 newtons to two significant figures, or even 4 newtons to one significant figure. And final thing, to finish this question off, would be to take into account the direction. So it would be negative because of the convention we're using. Okay? So that's the vertical component of the force. Similarly, for the horizontal component, that's going to be h times the cosine of theta. So it's going to be 6 times the cosine of 40 degrees, which is 4.596. So again, rounding, we'd call that newtons to two significant figures. It's important to put in the significant figure so somebody knows you've rounded it. And again, because of the convention we've chosen, it's negative. We've called forces to the right positive, So that will be negative. And that's that first question done. You know that I am interested in accuracy and units, so that's what I'm after. I'm after not only the value of the force, but the value of the force to an appropriate accuracy with the units. So in this question, we're given this formula for the area of a trapezium. This is a trapezium, something that has two parallel sides, and the fact that they're parallel is indicated by the arrow, and sides that are not necessarily parallel makes it a trapezium. So there it is. And actually the formula comes from, this bit comes from averaging. This is an average of the two sides A and B in attempting to make it look like a rectangle with a side which is the average of the two, A and B. So that's where the formula comes from, but we need to remember it, well, not necessarily remember it, but be able to use it, half A plus B times H. H is assuming it's the vertical distance, so in another problem you might have to find H by using Pythagoras. You might have enough information to be able to use Pythagoras to find this side, but at the moment we're just taking as is, so Pythagoras could well come into problems involving this sort of thing. But we've got to rearrange it for B, so area is a half A plus B times H. That's the formula that we've been given. We've got to rearrange for B. Well, you might not write it like this, but remember half of something is the same as dividing it by 2. So I could just as easily think of this as A plus B all divided by 2. I might not write it like that, but it's useful to think of it like that. So to get rid of that denominator, I just multiply both sides by 2. Multiply by 2 to get rid of the half. So 2A equals A plus B times the height. Now at this point you might decide that you'll multiply out the brackets. But remember we're trying to get B on its own. So if I multiply out this bracket, I'm going to be multiplying B by H to get a term involving BH, which is probably not going to be useful because I want to get B on its own. So it's not a good idea in this instance to multiply out the brackets. What I want to do is to get rid of the fact that it's multiplied by H. By doing what? Divide by H, right. Divide both sides by H. 2A over H equals A plus B. Now we're virtually there because I want to get B, so I could just as easily be asked to find A, and it's the same step at the final point. Subtract A from both sides to get rid of that A. So B equals 2A over H minus A, and that will be the formula. Okay, this question then is a back of the envelope type question calculation that you might well have to do just as part of a bigger calculation that you're involved in. You know, what diameter circle do I need to give me this area is the question. And so you should have all the information in your head really that you need to do this. I need to know two pieces of information. One is the formula for the area of a circle, which is pi r squared, and the other one is the fact that the diameter is twice the radius. So with that information in mind, my plan is going to be to rearrange that formula on the left to find the radius because I know the area, and once I've done that, double that to get the diameter. So that's what I'm going to do. So to rearrange the formula, r squared. So at some point I'm going to have to square root, but I don't do that yet because the r squared is multiplied by pi. So the first thing to do is divide both sides by pi, and I get the area over pi is r squared. So if you're going to square root something to get rid of the square, get that, whatever it is, on its own first, generally. So r squared equals a over pi. So now, square rooting both sides, I get the radius is the square root of A over pi. So now I can find the radius. It's the square root of A, which is 12.6, over pi. And then I'll just leave that answer in the calculator and just times it by 2 to get the diameter. So the diameter is 2 times whatever the answer is. I could even do it in one hit and times this by 2. At this point here, I could just do times 2, and it gives it to me. And I get a diameter of centimetres to 2 significant figures. Did you say 2? 3. No, it is 3. Yeah. Good. Well done. 3 significant figures. So number 4, I think it's important to know some key formulae, and this is one of them. We think of our cylinder, and I've talked about this before, so this is a reminder. This is a prism, which means that if I were to cut this anywhere, the cross-sectional area would be the same. So that's the definition of a prism. And in a prism, the volume is always the area of the end times by the length. So in this case, the volume is the area of the end, which is the circle, so that's pi r squared times the length. So this idea of the prism is worth remembering. Just make this note, because of course if it had been something like this, then you would be able to know immediately what the volume of that was, because it would be the area of the end, and the area of a triangle is half base times height. So the volume would be half base times height times the length, where again the height would be this vertical height here. And so you might need to use Pythagoras, as we've discussed before, to find out what that vertical height is. But the formula for the volume, again, is just the area of the end multiplied by the length. So that's worth remembering. For a prism, that's always the case. Okay, let's have a look at this question then. First off, in an electrical situation or electronics environment, this again is a bit of a back-of-the-envelope calculation. So you're expected to have in your head, really, if you're using this sort of stuff, the ability to do that without recourse to a textbook or anything like that. You probably need a calculator for the final calculation, but apart from that, you will get to know what the formula is. The formula that relates to charge, the capacitance and the voltage across in a circuit like this. So we've got that Q equals CV. But I want the voltage, so I need to be able to rearrange that for V. V is d times by C, so divide both sides by C, and we get V equals Q over C. So I've got the formula. Now I need the information. So I know that C is 650 microfarads. But I need to convert that to its base unit, which is 650 times 10 to the minus 6 farads, because micro is 10 to the minus 6. So I need to know that. And then I've given the charge. I need the charge, and that's 1.3 millicoulombs, which is 1.3 times 10 to the minus 3 coulombs. So this information should be in your head. And now all you do is get your calculator out and say, so therefore the voltage is going to be 1.3 times 10 to the minus 3, thank you, over 650 times 10 to the minus 6. And then out comes the answer, to an appropriate accuracy.